Okay, so this video is meant for my geometry students. This is your test review for the test on Friday, last major grade of the quarter, so we really need a good showing here to help our grades out, and this is going to cover just sections 5 and 6, a lot of proofs. I would suggest you watch this video and the previous one as a comprehensive review for your test. Okay, so here's our first problem. Simply name the property of equality or congruence that justifies going from the first step to the second step. So the question is in this problem, problem A, if segment XZ is congruent to segment TZ, why can I say then that segment TZ is congruent to segment XY? This one is commonly missed. It was missed on the homework check a lot. This is not reflexive property. Reflexive property is the same thing on both sides. That's not true. What happened is the left and right side flipped. So this is symmetric property. Okay? Symmetric property. Now let's see number 8, or part B. Angle A is congruent to angle B, and angle B is congruent to angle C. Then angle A is congruent to angle C. What goes from step 1 to step 2? Well, remember, when one ends, how the other begins, this is transitive property. Remember, it's just like the law of syllogism. That's transitive property. And that's all. So, you'll have some problems like this, but most of the time it's going to be in the proof. Okay, so here is our next problem. We're going to write a proof for this problem, and it says, given that E is the midpoint of segment DF, show that DE is 23. And you have this picture here. So here's what I have. I have, over here I have my two columns. Don't laugh at my squiggly lines. And then I have my thoughts over here. Remember, it's very important to think about what's going on. So first thing I'll do is I'll fill in the given. E is midpoint of DF. And again, that's given to me. So on my picture, what I should do is I should mark the fact that E is the midpoint of DF. If E is the midpoint of DF, I know that DE and EF are congruent. This is immediately going in my thoughts. So DE is congruent to EF. You could also say, or DE is equal to EF. Whichever one is more convenient for this proof. Okay? So there's that. I'm also going to write down what I want to prove down here. DE equals 23. Keep that in mind. So the other thing I know is I know that DE is 6x plus 5, and I know that EF is 8x minus 1. So those are all good thoughts to have. So how can they help my proof? Well, if E is the midpoint of DF, we know that these two parts are congruent, or they're equal. Now notice I want to show that DE is equal to 23, so stay away from congruence. Use this equals. So stay away from this thought. Use this one instead. So we're going to use that and say that DE equals EF. And it's all because of this fact that it's a midpoint. That's what a midpoint does. So definition of a midpoint. That's it. You could also write that a midpoint bisects a segment, a midpoint splits into two equal parts. I don't care. So then it would make sense that if DE is 6x plus 5 and EF is 8x minus 1, plug them in. 6x plus 5 equals 8x minus 1. And that's just substitution. Okay. So now I want to get the 6x's to the 6x and the 8x together. So I'm going to subtract 6x. So the fourth step is going to say 5 equals, when I subtract 6x, that's 2x minus 1. That's subtraction property. And then I'm going to add 1 to both sides, so 6 equals 2x, and that's addition property. And then I'm going to divide by 2. And there's my x value, and I use division property. Okay? So I'm actually going to erase this right here, because I need some room. Okay, I know what I need to prove. I need to prove this guy. So let's take a look. Now that I have x, plug it into DE. That's what I want to find, right? So DE equals 6 times x plus 5. That's just substitution. I'm going to scroll down, scroll up a little bit. So then lastly, just simplify. That's 18 plus 3, that's 23. And that's exactly what I want to show, that DE is 23. And it's not prove, it's what we did. We simplified. So simplify. There we go. And that's this. This is a segment proof involving a midpoint, but it's more algebraic than anything else. Okay, here's my next proof that I want to do. Notice the first thing I see is there's angles involved. So this is an angle proof. I also notice that there's no x's or numbers. So this is more of just a straight geometry proof. Okay, these are a little bit tougher, but we'll walk you through it and we'll do good. Always start with the given. The measure of angle PMN equals the measure of angle, shout out to RBC. Let me move that over just a little bit. I wonder if they thought about Twinsburg when they wrote this proof, right? RBC. I was just pausing for your laughter, that's all. So that's why I didn't say anything there. Okay, so there's the given. And I'm going to mark that on my picture, right? Very important that angle PMN is equal to RBC, so that means they're the same. They're congruent. And that's very important. Look at that. Maybe we could just slide PMN right in. Let's see what we can do. So now we want to prove that, and I'm going to write that over here, that the measure of angle ABR plus the measure of angle PMN equals the measure of angle ABC. I want to prove that. That's what I want to prove. So that just goes down there. So what are some thoughts I have? Well, I have one major thought, and it comes from this figure right here. I know that using the angle addition postulate, ABR, the measure of angle ABR, plus the measure of angle RBC is equal to that entire angle, measure of angle ABC. I know that statement. And then if I look at the proof, look, it's almost exactly the same. The only thing is, this is different than the proof. Right? Look at the proof. It's PMN. But look at our given. Oh, they're the same. So maybe this is a pretty simple proof. All right, let's see. So I think that's all the thoughts we need right now. So I'm going to write that the measure of angle ABR plus the measure of angle RBC equals, I'm going to roll over. You don't have to if you can have room. Equals the measure of angle ABC. And that's just from the angle addition postulate, that first problem. Angle add postulate. So now I want to prove this right here. Well, look. If RBC is here, I want it to become PMN. Look, RBC is here. It's equal to PMN. Plug it in. The measure of angle ABR plus the measure of angle, not RBC, but what it's equal to, PMN, equals the measure of angle ABC. And I'm going to erase this bottom because I think that's exactly what I want to prove. So you could have just moved it on up. Right? That's what I want to prove. ABR plus PMN equals ABC. I've done that, and all I did was a simple substitution. And there we go. Substitute. Sure. And that's this angle addition proof. Alright, so this was straight geometry. Not too long, right? There's not a lot of steps. You're not adding things, subtracting things. Pretty straightforward. Alright, here's our next problem. We just need to find x, and you have to justify. Now, I mentioned this in class. When I say justify, I want you to tell me, why did you create your initial equation? What kind of angles are they? Okay, so in this first problem here, A, I see these two angles right here, and it looks like they are adjacent, and they form this straight line. So you can tell me that they are a linear pair, or tell me that they're supplementary, because you know that a linear pair is supplementary. But that initial equation better say x minus 27 plus 4 plus 12 equals 180. Better say that. Okay? Better say that. So now we combine our like terms. 5x minus 15 equals 180, right? X and 4x is 5x. Negative 27 and positive 12 is negative 15. excuse me. Add your 15 to both sides. 5x equals 195, and then let me scoot this down just a little bit, and then divide by 5 to get x equals 39. Excuse me, and there's your value of x in problem A. Now, in problem B, let me use yellow. Problem B, if you look at these two angles, 3x plus 2, here's one of its sides, and here's the other side. Notice that it forms opposite rays with the sides of 6x minus 18. These are vertical angles. Vertical angles. And we know that vertical angles are congruent, or their measures are equal. So 3x plus 2 is equal to 6x minus 118. I will subtract 3x from both sides to give me 2 equals 3x minus 118. I'll add 118 to both sides to get me 120 equals 3x. Let me slide this down just a little bit. So then I'll divide by 3. And there is my wonderful value of x, 40. So again, don't miss stupid points because you don't justify. When I say justify, tell me what kind of angles they are. Okay, here comes everybody's favorite algebra problem. I want to figure out what this angle is. Its measure is 20 less than the measure of its complement. What is this angle? What is that measure? Okay, the measure of the one angle. Well, when you do this problem, there are going to be two angles involved. So the measure of the angle you want to find, you just call it the angle. We need to let it be something. Let it be x. Okay, so it's just x. Okay. Now we search for that special word, supplement or complement. That's the other angle. And you look here, complement. So we are working with a complement in this problem. And the complement is what you need to make 90 with x. Well, to do that, you take 90 and you subtract x. And I might suggest you put it in parentheses. So now we need to create an equation. Well, find your equal sign. Is means equals. What is on the left side? The measure of one angle. That's this guy. That's the top guy. That's x. Is equals 20 less than the measure of its complement. Well, this is that backwards. It's this backwards wording. 20 less is minus 20. So the complement is 90 minus x, and 20 less than that would be minus 20. And there's your equation. And now it shouldn't be too hard to solve. First, the parentheses can go away because you're not multiplying by anything. So this is just x equals, we combine the 90 and the minus 20, get 70. Now we're going to add x to both sides to get 2x equals 70, and we're going to divide by 2. And x is 35. So what are our two angles, or what is the angle? The answer is 35 degrees. But to check, let's see, this is 35 degrees. 90 minus 35 is 55 degrees. The big thing was that my angle is 20 less than its complement. What is 35? It's 20 less than 55. Boom. Magic. So if you have trouble, go on Interact Math and see if there's problems like this, okay? Because you just need to practice them. More practice, perfect. Practice makes perfect. There's one of these on the, I think it's on the quiz or test review for Chapter 1. So go back and look at that one too on that video, okay? But tackle these and dominate these. Don't let them trip you up. All right, so here's our next problem. I guess I should say up here, write a proof. Write a proof, okay? Another angle proof here, okay? So let's see what we can do here. And notice I see x's and numbers and stuff, so that's algebraic. So maybe we should feel more comfortable, okay? So first thing I'm going to write down is my given. Angle A is congruent to angle BDA. That's given to me, okay? So now I'm going to look at my thoughts. I'm going to say, okay, well, I know, looking at this, that the two angles in question, and I'll mark this. Are angle A, which is right here, and angle BDA, which is right here. These are the two angles I need to know. Okay. All right. Well, let's talk a little bit, because this is kind of like, I thought it was a little bit simpler, but it's a little bit more involved. If we look at these two angles, we know nothing about this right here. Know nothing. It's a question mark. But notice right across from it, this angle, angle BDA, is congruent to another angle. It's congruent to angle CDE because they're vertical. And we know that vertical angles are congruent. So we know two measures. We know the measure of angle A is 11x plus 20. We'll use that. And we know that the measure of angle CDE is 12x plus 15. We're going to have to use that too. We're going to have to use that as well. Okay? So all of these things are going to be needed to show that x is 5. All right. And again, let's make sure I forgot to do this. I'm going to put it way down here because I don't know how long it's going to take. So what I would do is I would stick with congruence. We know that angle A is congruent to angle BDA. Let's use this thought next. Angle BDA is congruent to angle CDE. We know that again because they're vertical angles, and by the vertical angles theorem, vertical angles are congruent. Vertical angles theorem. So I use that thought. So now, if we look at your two statements. Angle A is congruent to angle BDA. Angle BDA is congruent to angle CDE. This is a nice transitive property. Angle A is congruent to angle CDE. Now this is new. We didn't really think about that. I failed to mention that, but if you look at these two steps, step 1 combines with step 2 using the transitive property to get you step 3. This is transitive property. Transitive. Okay. Now if I look at my thoughts, equals. This says congruence. X equals. Get this out of congruence and into equality. It's simple. The measure of angle A equals the measure of angle CDE. Whenever you go from congruence to equality, it's definition of congruent and then whatever you're talking about. These are angles. Now, I think I know what angle A is. It's 11x plus 20. Let's plug it in. I think I know what CD is. It's 12x plus 15. Let's plug it in. And when you plug stuff in, that's just substitution. That's all it is. We're just doing some substitution. Okay. So I'm going to scoot this down a little bit. I'm going to erase this proof because I think I need a lot more room. Maybe I'm wrong, but and I'm going to extend my line. So now we need to solve for x. So let's subtract 11x from both sides. 20 equals x plus 15. I subtracted 11x from both sides. That's subtraction property. And now I'm going to subtract 15 from both sides to get the x by itself. And this says 5 equals x, right, when I subtract 15. And that is, again, subtraction property. And now this is kind of ticky-tack, but notice my proof. If you look up here, x equals 5. This says 5 equals x. I haven't proven what I wanted to prove. I proved that 5 equals x. Well, I think I can easily say x equals 5 because we have a nice property where I can flip it around the equal sign called the symmetric property. So that's kind of a ticky-tack, like, who cares? But that's what I wanted to prove. And this is the algebraic proof. If I get it all, there you go. So it incorporated vertical angles and just some algebra. It's a great proof. It's a great proof. Okay, this is the last problem I have for you guys. So again, you just saw it. I've done 4 proofs. A lot of proofs on this test. So get yourself comfortable with doing proofs. Okay? First, write the given down. We are given that the measure of angle BOF equals the measure of angle FOD. So we know that BOF is the same as FOD. And I want to show that 2 times the measure of angle BOF equals the measure of angle AOE. is what I want to show. Okay? So, what are some thoughts? Well, let's look at our picture. I see that the measure of angle BOF plus the measure of angle FOD equals the measure of angle BOD. I see that on the right side here. That's angle addition. And if I look here, I can make BOF and FOD the same thing because they're equal. So I think that's how I get the two BOF. So it looks like I need this guy to leave. And it's going to become another BOF. That's how I get my two BOFs. Now the question is, how do I make BOD become AOE? Well, look at the picture. BOD and AOE, they're vertical angles. So I also know that angle BOD is congruent to angle AOE because they're vertical. So here are all the pre-thoughts I'm having, and we'll have to do a little algebra here and there and some substitution, but this is the big idea. We have angle addition, sorry for the scoot up. We have angle addition and we have vertical angles. So let's start with the angle addition. So the measure of angle BOF plus the measure of angle FOD equals the measure of angle BOD. First was given, this is angle addition postulate. Now, I want this to say 2 times the measure of angle BOF. So I need 2 BOFs here. Well, just like I spoke earlier, FOD is here and here. I can make BOF go in for FOD. I can replace it because they're equal. So I can replace and say that the measure of angle BOF plus the measure of angle BOF equals the measure of angle BOD. I can say that, and just by doing a simple substitution of 1 and 2. Substitute. So 1 and 2 are now gone. They've become 3. So now if I have 1 BOF and 2 BOF, I have 2 BOF, right? If I have 1 and 1, add them together. 2 measures of angle BOF equals, so that's these two, equals the measure of angle BOD. And I just combine like terms. These are the same thing. I just combined like terms. I'm going to slide down to give myself some more room. And now I'm going to erase this because look, I've got the left side. Now it's about getting the right side. Well, we have to bring in the vertical angles idea. We talked about this thought already. So now we have to bring in this thought. So that's next. So based on my picture, angle BOD is congruent to angle AOE. And it is again because they are vertical angles, and we know that vertical angles are congruent by the vertical angles theorem. Vertical angles are congruent. Now notice we have equality up above and congruence. We can't intermix the two. So change this congruence into equality. So 5 is going to turn into 6 by just saying that the measure of angle BOD is equal to the measure of angle AOE. And that is just simply definition of congruent angles. And now we're there, because look at your 2 steps. 4 and 6. 5 is gone. 5 became 6. So look, 2 angle BOFs equals BOD. Angle BOD equals angle AOE. So now, by transitive property, 2 measure of angle BOFs equal the measure of angle AOE. And that, again, is by transitive property. Okay? So now, on the test, a lot of these proofs will be filled in for you. So don't think you have to come up with all this on your own. There's a couple that are empty, so you have to be able to think and process logically, but for the most part, fill in with the reasons. So again, I made them difficult just to show you the difficult proofs, but expect some easier ones tomorrow on the test. Okay? Thanks for watching. Hope this helped. Have a great rest of the day.